Any questions from the audience or from the people online? There's one.
Hi, I'm Christian Carli from INAFIAPS, and I have we can say a couple of questions, one following the other, two for Jessica, and our colleagues Rachel and so on. Janice, yes, sorry. The one is which is the difference of temperature on the images taken at midday and images taken in the morning? And this is related to the fact that this weak bands at around 3 microns is often seen also in the nominal anhydrous silicates, measured in terrestrial or in vacuum. And I was just wondering if how we can say trust in some way that is related to the presence of OH, since those minerals are often with just ppm of water or better of hydrogen bonded in the crystal, and is not instead just a typical absorption related to the silicates, since measuring OH in this mineral is difficult also with the transmittance measurement, so in absorbance. And so if this, then the difference that we see could be just related to a difference of temperature on those absorption related to pyroxene or olivine and so on, that is not anyway potentially attributable to water. So there is any connective activity on the lab to enter much more in details on this problem, to understand if we are really seeing from remote sensing water in that areas, or is just related to some absorption due to pyroxene, olivine, or plagioclase.
So the spectra that I showed were measured under controlled dry environments. So the samples were put in the instrument and then the water was purged out overnight. So it should have removed all of the adsorbed water. So the water and OH bands should be from inclusions or OH or H2O actually bound to the surfaces. But those were all measured just at room temperature. And I actually have a Europlanet grant to visit Alessandro Matarilli at the DLR in Berlin. And we're going to do some reflectance and emission spectra this fall, where we're looking under vacuum and under higher temperatures to try to get a better idea of how this might change, how the spectrum might change in this region. And then for the M-cubed data, there is a change in temperature of the moon from the morning to the midday to the afternoon, and it is warmer during the midday temperatures. And I don't recall right now what those temperatures actually are. And it's difficult. When we get the Trailblazer data, it's going to be so much better. But right now we've got to work with what we have. And so the M-cubed data is at a range of temperatures. So there's sort of morning-ish data is somewhat classified together and midday data is somewhat classified together, but there are variations in the heights and variations in the temperatures for each of those categories. So it's not really like comparing apples to apples, but we're doing the best we can with the data that's available right now.
Right, thank you. Any further questions from the audience? Okay.
Can I ask one?
Yes, sure.
I'd like to ask Lee a question. So as you mentioned, the atom probe is pretty well known in the surface physics community, and they typically have like tips. You circumvented that a little bit by using the laser. But the laser itself, when you do the impact on the tip, that creates a little plasma before you have melting. So I'm wondering how much of the ionization you see is actually due to the laser interaction versus the field emission from the tip.
So the way that's kind of controlled is through the temperature of the tip. So by keeping it at 50 Kelvin, in theory, you're minimizing those kind of thermal effects. And the hit rate, if you like, is always controlled by the instrument. So it's automated to try and keep the tip at that temperature. So the biggest issue would be from the fib preparation, the focused ion beam. So especially if you use one of the old gallium source fibs, there have been examples of sort of nanometer scale amorphization of your regions of interest. So that's why we always keep those capping layers on the top. But yeah, beyond that, it should be fairly real from the sample. So we shouldn't be inducing too many artifacts. And at least by looking at the known terrestrial standards and some of the experimental work other groups have done, it does seem to be a real space weathering signature that we're picking up rather than induced by the atom probe. So if it was a common problem, you expect to see it in kind of all of our data sets, which we don't.
I have a question for Thomas and or Brandt, if that's okay. I was wondering about some of the surface reactions that you showed with the olivine structure, and what are your thoughts on the moon about some kind of exosphere, or how do you feel about molecules attached directly to the olivine versus some that might float off and then reattach? Is that a reasonable scenario to you, or not really? I've heard others mention that.
Yeah, it's definitely a possibility. Generally, it's called, in particularly for water, when it interacts with the surface, it can either, can be absorbed as water whole, or it can dissociatively attach. And what that means is that it just breaks apart into surface hydroxyls again. As far as an exosphere goes, I do think that there's an exosphere. I mean, there's obviously a lot of hydrogen bouncing around too, but I also think that there's a lot of, well, I shouldn't say a lot, but some amount of water bouncing around too. And I do think that that probably scales with the height. So, if water is desorbing from the surface and due to the really fractal nature of the grains, it probably doesn't have the kind of typical cosine distribution that a flat surface does, right? So you probably get these really shallow angles of a launch trajectory with an equal probability as you would as like a purely vertical or at a 45 degree. And so what that probably ends up with is that you have a higher number density of water in this particular example, really close to the surface, and it decreases significantly as you go higher from the surface.
I want to add one thing to that, and we didn't talk about it because we had the parlance of water removal and desorption primarily by thermal processes. But the Lima alpha photon and the photon impinging on the lunar surface has a very high cross-section for photodesorption, which is a non-thermal process. And so, right at the surface, due to the photodesorption event itself, there should be very little water hanging out directly on the surface.
Okay, just sorry.
From what both of you said, it sounds like it could be possible for water that's chemisorbed onto the surface to be released and then reattached in a chemisorbed manner. And potentially that could be happening in a diurnal pattern, and potentially also electrons could be involved in that process as well as temperature.
Yeah. So in that model that I showed, the strongest diurnal effect was from chemisorbed water. There was a small diurnal change just from the internal OH, but it was not as big as what we've seen in observations. So
Okay.
in my opinion, the big change that we're seeing is probably adsorbed chemisorbed water.
Okay. We've only time for a very quick last question, maybe to Chloe. If not, I'm going to ask something. So I very much liked your experiments in the lab with the buried ice and buried water. Are you planning to test with regolith ice mixtures? As you indicated, the attenuation would then be different due to probably interface coupling effects.
Yes, indeed. We are thinking about how to recreate a mixture of grains of ice mixed with grains of regolith. And of course, we have to modify our facility for doing so. So it's not so easy as it can be. So.
Yeah, looking forward to that. Thank you all the speakers again.